So what we have here is a very cheap multimeter, or as it says here, multi-tester. Bought from DealExtreme. It's like €4. It wasn't very expensive at all. It's one of those things I just bought on a whim because I was actually buying rare earth magnets and various other bits and pieces. Anyway, I do have a thing for analog multimeters. I know they're not as accurate as digital multimeters. Even when they are accurate, no, let's be honest, and it's hard to read where exactly the needle is stopped on the readout. Sorry, I banged the camera stand there. But you know, I like the aesthetic, and for educational purposes, if you're trying to get children into electronics, an analog multimeter is always better because you get instant feedback. You know, the dial moves around, it jumps. Children like that. Find with digital multimeters, they kind of get impatient when they're waiting for the numbers to sort of settle down. You know, you test something 3 volts and it sort of goes up 3.1, 2.9. It bounces around until it settles. With these, they see instant response. They see the changes, and that gets kids engaged. But anyway, enough waffling on. Let's have a look at it. Okay, the back of it is in Chinese. I can't read Chinese. That's in Chinese too. Obviously quality control is not paramount here because they just like slid this in and stapled it in place, so it's not even covering the whole box. But for €4, $4, whatever it was, who can complain? So let's have a look inside. Oh, that's interesting. A block diagram. A circuit diagram. I wonder how accurate that is. I'm not really going to do an in-depth test here. I'm just going to sort of show you roughly how accurate this thing is compared to, say, a top quality multimeter and a sort of mid-range sort of €15 digital multimeter. So anyway, here's the probes. They feel cheap and tacky. This is made out of that sort of plastic you could almost scrape off with your fingers. Yep, you can do that. The black one feels better though. The black one's more sturdy. Let's have a look. What have we got here? Ohm by 10 by 100 by 1000. DC voltage up to 1000. AC voltage up to 1000 and DC milliamps. So it basically can test AC voltage, DC voltage, resist a small amount of resistance, and DC amps. I don't think I would be putting 1000 or even 250 AC volts into this. 50 might even be a push. It doesn't feel like it would be very safe. And the same with DC. It feels cheap and tacky. So it wobbles, and it's kind of, the plastic has that sort of strange rubbery sort of feeling to it. It's not rubber, but it has a kind of feeling that you could just scratch stuff into it. Let's see. Yeah, it's easy. It's cheap and tacky. Alright, let's see what it says. To avoid electric shock. Not very well printed. Disconnect measuring terminals before removing battery. Replace only with the same type of battery. Okay, let's see what kind of battery it takes. Oh, that looks like a AA, which I happen to have here. Maplin's finest. I wonder if Maplin was named after the holiday camp in Heidi High. Hello campers, Heidi High, hooty hoo. It looks like it's the right size for a AA, but not quite. That doesn't bode well. I seem to have bent that out to get it in. Whoa, is that just... That's just that piece of strip of metal. It's not a wire. Normally I would expect some wire to be attached to the terminals. But they've literally just soldered the metal into the metal terminals or directly to the circuit board. Never seen that before. No, that's not going in. I want... Ah, hold on, there goes one. Let's see. Oh, what's this? There's a slider of some kind here. What does it do? See if I put it under DC volts. Is that for balancing it and calibrating it? No, you wouldn't know. That's probably what that is. Yeah, that's for calibrating it to 0. Curious. Looks like a very cheap and nasty potentiometer, is it? Yeah, it looks like a cheap and nasty one. So let's do some tests. I want to compare how well this works with a decent multimeter, and then I'll come back and tear it down. I'm not expecting good things from it, to be honest with you. Okay, so what we have here is a €15 or £10 in England Maplin home multimeter. It does voltage, AC, DC voltage, ohms, and has continuity tester, also the diode tester. I actually use this for when I'm out and about with my radio, and I need to test something because I found it to be pretty decent. So what I'm actually going to do is test the battery. It's a brand new battery, alkaline, so it should be 1.5 volts. So change the range. High in. 1415. It's jumping around a bit, but you know, I can live with that. Let's take a better multimeter, a Uni-T. Doesn't exactly have the same cachet as, say, Fluke, but it's still what you'd call higher end, in my opinion. Over limit, let's range it. Oh, millivolts. There we go. And it's gone to AC. There we go. Interesting. Very interesting indeed. That was coming out 1415. That's coming out 16. Let's have a look at this thing. Let's move it to DC 10 and put the probes in. Horrible, cheap, nasty probes. Turn that off. Now this is where it might get hard to spot what's going on here. I thought I corrected that, but it's not sitting. Hold on a second, I need to fix this. It's very hard to get it on. Yay! That was unexpected. And really, you don't want the multimeter covers opening up when you're using them, because exposing live parts, and especially if you're testing main stuff. Not that I would use this to test mains. It'd be freaking mental if you did that. See what it's coming up with. So it's sort of sitting on that 2 there. Now the problem is, if we look closely at it, there doesn't appear to be DC voltage scale. So what's that? That looks like resistance. This is that resistance as well? Because it says O here, ohm symbol. Voltage milliamps in black, so that would be that. AC 10 volt scale here. And decibels. Why is there a decibel scale? AC voltage range, add this. Huh. Curious. So it stopped on 2. Let me change the DC voltage range. It stopped on 2 AC volts, which doesn't make any sense at all. But this way, just try and check something else here. Barely registered. So that's the correct scale. No, the 10 for whatever way this has been set up. See, now it's below 2. It was on 2 the last time. Wee, wee, wee. Yeah, I don't like how it doesn't seem to sort of settle back at the same place each time. So let's give it an acid test of sorts. I'm going to use my bench supply. Turn it up to, see, I'll put it up to 3 volts. I don't want to push me luck. Yeah, so my bench supply is set up to 3 volts. Got the output switched off at the moment. I'll attach these. Hopefully there won't be any explosions. Do you see what's going on here? No, something's... So it's kind of in between 2 and 4, so maybe it's getting this right. Well, I'm working off the AC 10 volt scale, which I'm assuming is DC volts. So let me just, I'm going to actually start varying the voltage, just so you can see the needle moving. So we're up to 6 volts, and that is on 6. So, you know, not bad at all. So what I'm going to do, well, it reacts. I'm not saying that's a good or a bad thing. So let's take it down to 3 volts. Sorry, it's a bit sensitive. Let's turn it off. There. And I'm going to turn it on again. This time I'm going to increase. I'm going to start checking the current. It's like this 0.5 milliamp. Let's see what happens when I upgrade up the current. Nothing. The voltage. Yeah, it's not looking good, is it? Turn that off now. I think you know where I'm going with this. It's rubbish. It's a pile of crap, and I still haven't figured out what that is. Turn off my overmeter. So let's open it up and have a look inside. You know, I wasn't actually, when I bought this, I wasn't seriously suggesting I was going to use it for actual workshop use, because you know, I didn't expect it to be used in the workshop. Just curiosity, just want to check one thing. So I've taken the battery out. I'm going to put the probes back in. And reattach the power supply. terrible. They don't stay in. While this is happening, I'll sing you a little song. I know a song that'll get on your nerves, get on your nerves, get on your nerves. I know a song that'll get on your nerves and it goes on. No, actually, I don't want to do that. Put it back to voltage. So there's no battery in it. And switch it on. Turn it up to 3. Okay, that's weird. I'm at 3 volts, and it's up to 6. So let's take it down. Take it to 3. Well, that's 1.7. So, and it's saying 3 volts. So, yeah. So it does do something without the batteries in it. Let's see, I'll just take these, let's just take the probes out and finish off dismantling it. I don't suspect I'm going to be putting this back together again. What have we got here? 3. Throw another screw. What sort of screw is that? Doesn't appear to have. Seems to be smaller than the rest. There we go. Let's see if that comes out now. Oh! What the? So let's see, there's where there's the, well, generally the way these things work is it creates a magnetic field on at the base of the needle, and it has to be calibrated. So when you're passing a voltage, that will affect a magnetic field, which in turn will pull on a magnet which is attached to the bottom, to the needle, which is effectively doing a sort of cantilevering the needle. You're sort of pulling at the bottom, and that tilts the long end. But yeah, this is basic. I was expecting to see a lot more than that. So we got the voltage, like take for example, the voltage comes out here along, this is 10 volts. You got the inner trace as well, so sort of switch it, no, so the inner trace is the power, effectively opening up joins the two together. So if you look at this, the actual rotator, it's actually got 3 contacts, and it looks like the resistance side of it has got 3 contacts. But if I follow the trace around, goes into a resistor into the battery. So I need to take the inner trace. Where does that go? So the inner trace comes in here, through there. So effectively, what it's doing is, in the case of voltage, passing the incoming current through one of several resistors and passing that on to the needle and the dial. So the resistors are effectively, if I can get this out, the resistors, I was basically telling it how to choose between the different voltage levels. and calibrate accordingly, which is a very poor way of doing it, to be honest with you. Well, of course, what do you expect for €4, $4? So let's just pull out this. Okay. What have we got here? So yeah, what you have here is effectively a magnetic field. This is like would be very similar to the inside of a motor. You've got the power comes in, and that causes this coil to rotate, and there's a slight spring on it to push it back to the 0 position. So it always wants to return here. But what happens is when there's any sort of power coming in here, that'll sort of cause this to tilt over a certain amount, and then you have to make sure that the gradients, the scales on your meter are calibrated to match with this. But that would be pretty standard. If you took apart even a high-end analog meter, you'd probably find a very, very similar sort of arrangement on the needle. But this is just, it's not worth it really. You would expect a lot more on the board, to be honest with you, to maintain accuracy. And here's the thing: I wouldn't it's talking like, what was it? How many AC volts? 50, 250,000. Same for the DC volts. Seriously, if you put like that, even 50 might burn this out. Like those traces are just so skinny. Yeah. What is that dial? It could. Oh, is it? I think it might be some sort of calibration for resistance. Yeah, it comes down into the resistance contacts. Is it possible that what you're meant to do is take a resistor of known value, say 100 ohms, and then twist this until you get 100 ohms on here, and then you can test them with accuracy? Possibly, who knows? Either way, it's rubbish. No, you knew that anyway. That being said, if you want something for kids to play around, if you're getting kids into electronics and they're only going to be using 1.5 volt batteries, this is a good way to sort of show them how electricity moves, how it changes. Or you could spend more on a quality analog meter, but I've done it anyway. I've taken it apart. Hope you enjoyed it. And now I'm going to sell myself out and say, please subscribe. Please. Okay, you don't have to if you don't want to. But anyway, bye-bye.